So this BTEC Sports Science video is for Unit 1 Physiology, and we're looking at learning AMA, the responses of body systems to exercise. Specifically, we're looking at A1, the skeletal system responses to exercise. So your specification has only two bullet points, I guess, two things that you need to cover for this system. Synovial fluid and osteoclast activity. Please notice is osteoclast activity. There are 3 bone cells. Your spec specifies osteoclast activity. And I will use the acronym SO, obviously, to teach this. So the assumption at this point is that you know what synovial joints are, how they're structured, and how each of these components function. So what synovial fluid is, it's this thick straw-like liquid that acts as a lubricant to reduce friction, the moving parts of these synovial joints. But what we need to look at for the physiology unit is, when we are exercising, how does it respond? How does synovial fluid respond? What's different when we exercise to when we're at rest? Let's have a look. So we actually produce and release more synovial fluid from the synovial membrane. So more is released into the joint, which kind of makes sense. If we're going to be moving more, we want more lubricant. Also, because typically when we exercise, tissues are warmed, so is the synovial fluid. And what that does, that warm fluid becomes more running, becomes less viscous. So we decrease the fluid's viscosity. That means thickness, making it more runny. And because it's more fluid and more runny, it is that we have smoother movements at that joint. We reduce friction, of course, between these bones and the articular cartilage, which allows us to move with greater range of movement, more mobility. And in a lot of our sports, if we can have a greater range of movement, we'll perform our skills and our techniques better, which is a performance advantage. Obviously, with the avoidance of friction, we won't experience pain, and it can also help a little bit in shock absorption. A secondary point is that this fluid can help nourish the articular cartilage. So this cartilage on the end of bones, we want that to be thick and healthy to keep protecting our bones. If this gets damaged or worn down through overuse or dries out, then we might suffer from arthritis, which can be really problematic. So the fluid production actually helps us keep healthy cartilage also. But these are your main points here to learn about synovial fluid and the increased release and reduced viscosity during exercise. Now, the second bullet point in the spec was about osteoclast activity. And just very quickly to recap, there are 3 bone cells you must know for the physiology unit. Osteocytes, which control the activity of the other 2 bone cells. Osteocytes control the process of bone remodeling so that we can maintain bone density. So they're like in charge of the activity of the other 2s. And we get osteocytes by osteoblasts getting trapped in the bony matrix and maturing and becoming osteocytes. Importantly, your spec will expect you to start a conversation about osteoclasts. Now, osteoclasts, simple term, clear out old bone. They break down old bone. The more accurate language is they reabsorb calcium. So they take away calcium from old bone, break it down. They actually release acid to degrade old bone, which clears the way and prepares the way for osteoclasts to come in and build new bone. So in simple terms, osteoclasts clear old bone, osteoblasts build new bone. But better language is resorption of calcium and deposition of calcium, i.e. laying down new calcium into the bone to make it strong, along with the depositing or deposition of collagen, that glue, that binding product. So these things make strong new bone. Osteoclasts break down old bone. Again, another bit of context that you should know from anatomy is that we age, we gain bone density as we're growing. So our bones get longer up until our sort of 20s, and thereabout sort of 20 to 30ish, we have developed our strongest bones that we're going to. So this is what we call peak bone density. After this point, whether you're male or female, your bone density will deteriorate. For women, unfortunately, it deteriorates more quickly particularly due to the loss of the hormone estrogen at menopause. And obviously that can bring problems in terms of bone strength, fractures, osteoporosis. But with the right nutrition, with the right food, with the right exercise, you can see by the red line, we can not only get a higher peak bone density, but we can delay or restrict the loss. We will still get weaker bones, but it won't be as severe as if we were inactive. So for physiology, the second skeletal response is osteoclast activity. So what happens when we are exercising is exercise is a stimulant for bone remodeling. It's Wolff's law. The more intense, the higher impact your activity, the more stress you put down through your bones, the more remodeling is stimulated. So it happens as a response to exercise. So exercise causes mechanical stress, basically little bits of damage in the bone. And then because of that damage from the exercise, osteocytes will detect this issue, detect this problem, and will basically stimulate osteoclasts to remodel. So the exercise brings about the activity of osteoclasts to begin that remodeling process. And they will then absorb the calcium, break down that old bone, and then start the process of then replacing it with new bone by osteoblasts. And ultimately, we deposit more calcium and phosphorus and collagen as well, which is a protein, so that we get new, stronger bone. So exercise causes osteoclast activity and then osteoblast activity to ultimately deposit new, strong bone. And if we have that going on, our bones become more dense and we have less chance of injury, fracture, or osteoporosis, and we will be better at coping with impact sports. And you can see here, this image here is of a tennis player. This is their dominant arm. So this is their humerus, their upper arm bone. And you can see that it's more dense compared to their non-racket arm. This bone gets more stress. This bone gets less stress and therefore has less remodeling and is less dense and is less strong. So just to summarize the osteoclast remodeling process, we've got certain kinds of exercise. It's not just any exercise. It needs to be weight bearing or impact exercise like running, jogging, walking, dance, or resistance exercise like weight training. So both of those categories of exercise will stimulate osteoclast activity, ultimately increasing remodeling, getting more dense bones. Be aware that things like swimming is not load bearing, and those sorts of exercise do not help stimulate bone density or bone remodeling in the same way as weight bearing or resistance do. So that there are two A1 skeletal system responses, SO, synovial fluid, osteoclast activity, and you can have a look at the summary page here.